Okay, this is somewhat the morning of Eric. So I give 2 talks this morning, and then you're going to have Eric Engstrom to round out the rest of the morning. So the second part, this is the issues on porting existing code, Windows code to Win32, and the types of things that you should be looking out for. The intent of this talk is to basically tell you about the 80% items that you all are going to bump into so that you're not making the discoveries yourself. Try to let you know it ahead of time. There we go. I have a note here. You need to speak louder during your talk, please. Okay. Basically, we'll talk about the portable Windows API, how to port, steps that you can use in order to port your application, various changes that we've had to make in the 32-bit API definition that affect portability, and just some of the, highlight some of the standard issues on taking 16-bit code to Win32, and we'll also do a couple of demos. We clearly want to position that there's one Windows API set. We've widened the existing 16-bit API to 32-bit, but it is a very familiar API. It is the same API. It basically has 2 forms, a segmented form and a linear form. Is it just a recompile? Well, yes. And so actually I'd like to do a quick demo showing what it's like to just try to recompile at least a smaller application. This is one of Charles Petzold's earlier Windows 3.0 samples. I did modify the makefile so that the makefile would build for Win32, but basically it was a random rec program. So without any changes to the source code at all, you can sort of see the date on the original sources is 1990. We go through the compile. I don't believe that there were any warnings in Charles's original code, but they're just warnings, so it actually seems to have compiled. So let's take a look and see what actually happens if we try to run this. I'm always game as long as it's compiled and linked. Okay, so it actually seems to have sort of worked. It does have some interesting features, though. It has the amazing new Win32 advanced feature of the amazing invisible title and window frame, which makes finding that system menu up here more difficult. Oh, there it is. All right. I don't believe that that's what Charles intended or would even want to document that as a new advanced feature of Win32. Anyway, well, so just wanted to show what basically that there is a lot of similarity in the API. I mean, there was a fair number of Win32 API calls there, and that was recompiled as a native 32-bit application. So we'll go through the rest of the talk and actually take a look at some more sizable porting issues and explain why that had the behavior that it did. Okay. It is straightforward to take one single set of sources and compile them, be able to compile them for 16 or 32 bits. Win32s is another opportunity where you can target Win 3.1 and Windows NT, but it's also possible to have single sources as well. We gained a lot of experience in designing the Win32 API through several efforts. An initial design of Win32 back about a year ago, or maybe a year and a half ago, we used that design to port all of the existing early Win 3.1 or 3.0 applets, things that we had, we needed to port for the shell. Found a bunch of design issues in the API ourselves before anybody had actually been exposed to them, and made API changes so that portability would be more straightforward. And so we suffered under our own initial design and made changes so that you wouldn't have to. There are also the porting lab experiences that we've had, have been mentioned here. A number of folks have come through our porting lab at Microsoft, and in sitting down and seeing a wider variety of code, we've also been able to affect the API design and features of the system, like shared DLL data being available on NT. That was something that was not there in the original design, but was added specifically because ISVs requested those features. So we're definitely interested in the feedback that you have in using the API, what new API we need to support and so forth. Generally, we've had folks try two different approaches, a bottom-up approach and a top-down approach. In the bottom-up approach, you basically run through all of your code, try to figure out everything that possibly could be affected by moving from 16 to 32-bit, do lots of work, try to do the whole breadth of your application, recompile it, and then it should just work. The other approach is the top-down approach, which we've actually found to be much more successful. You basically go through the SDK documentation, the programming techniques book that you'll all be receiving, which highlights what APIs or messages to look out for. You'll have the API spreadsheet that you can look and see which APIs we've had to drop, which are not supported from Windows 3.1 in Win32. You basically go through the obvious API changes. And modify the make files that you're building. You're already compiling, bumping into either compiler warnings, compiler errors, so you're actually building your application as soon as possible. Stub out the complex features. The first step is really get some things that compile, get your main window up and running. It's much more, it actually is psychologically much more interesting, beneficial, and also for management, presenting your demos to management, showing your Win32 application quickly running within merely a half hour after getting your SDK home. It actually has generally been true. We've had folks who have in several days in the porting lab or on their own, wherever, who have gotten their application into a state where it could be demoed. Things definitely that did not work, but you attack the additional features, the more complex features, one at a time, and there is the psychological benefit of seeing things and seeing new features get added in quickly. So once you've managed to actually, basically get it all ported over, you review and test all your code paths and ship your product. One of the issues, and when you take a look at the 2,000 pages of Win32 APIs, you begin to wonder, well, what should I be doing when I'm doing my initial port? I have all these new APIs. There seem to be multiple APIs that do the same thing. There are some advanced capabilities. Generally, we recommend just do the straight port first. If you're using Global Alloc today, there's no reason to switch to Virtual Alloc. Virtual Alloc offers sparse memory support and so forth. Global Alloc is fine. If you still have global locks in your code, they're okay. We no-op them out, but you don't actually need to lock pointers anymore. But leave them in your code. There's no reason to remove them. You don't have to switch to the C runtime if you're currently using _lread. We support _lread. So basically, do a straight port first. Then afterwards, you might want to look and see whether it makes sense to start using threads for background printing and so forth. And so the Win32 API does definitely have multiple ways that you can accomplish the same task or take advantage of advanced features. But the first criteria for the Win32 API was to make the portability issues straightforward. Okay, talk about some of the specifics. Line 1, WinMain. First changes you need to make. Basically, we're no longer a Pascal calling convention, and far pointers don't make any sense. Everything is our near 32-bit calls. These are pound defined to nothing in the Windows 32 headers. API is what you should use as the definition for callbacks and your entry points. Right now, we are a C-DECL calling convention. And by the time we reach September, we're going to be a new calling convention known as standard call for the Windows API itself. The
Standard calling convention actually has some of the benefits of Pascal calling convention and the C-decal calling conventions, and we'll provide some details about what that is. It's not particularly interesting at this particular moment, but again, you are C-decal calling conventions right now. The handle to a previous instance is always null. You're sitting in separate address spaces, you're sitting in a multitasking operating system. We couldn't guarantee, there'd be race conditions where we wouldn't be able to guarantee whether the handle that you received to a previous instance really was to a valid previous instance. Often that handle got used to pass data back and forth with get instance data, which really doesn't make sense in a separate address space environment. So you always receive null, which is generally the correct way to handle initialization in most code. You need to re-register your window classes for each instance of your application that loads anyway. Generally the path that people take through their initialization code is, they take one path for the first instance that comes up, and you generally are going to need to take that same path for each instance as it goes on Win32. Use additional or separate IPC mechanisms, DDE or name shared, named semaphores, or a number of the different issues if you actually need to either determine that there's a previous instance loaded or you need to manage communications between instances. Things like the control panel only likes one instance to be invoked, and so it just does a simple detect of whether another instance is already present. A change that we thought was beneficial is that the pointer to the command line now includes the name of the executable itself. It just doesn't point to the first parameter. So it was a change that we thought was useful. Okay, so the next change after line 1 on WinMain affects every one of your window procedure call definitions. Everything's been widened to 32 bits. The window handles, the message, WPRAM and LPRAM continues to be 32 bits. And so we're using a new data type, a uint. We'll talk a little bit about it later. But a uint is an unsigned integer, so it's 32 bits on Windows NT. And so you'll need to make that change because a large amount of Windows code today uses the word definition, which is a 16-bit value even on Windows NT. And in fact, this was the problem in the RANDirect sample that I compiled. It was losing 16-bit of rather significant data in WPRAM when it was trying to do the window creation, and some of the messages were being affected, causing that interesting side effect of the amazing invisible window frame. The other fact that we were a C-decal calling convention was part of the reason that we actually didn't GP fault even though we were losing data and doing some interesting stack manipulations there with pulling 32 bits off when in fact we only had put 16-bit on. There were, in moving to 32 bits and having handles move to 32 bits, this has caused an impact to a number of messages. There are less than 24 messages that were affected. Most of the messages are very obscure and or are only used maybe once in a handful or some applications of people in this room. So they're not, they're just not often called. However, there were some additional messages that are quite common, like WM command, WM get cell, set cell, but in particular WM command, in which the message repacking does affect everybody in this room. And so we'll talk about what some of those impacts were. The basic issues with WM command, WPRAM has widened. The LPRAM that used to hold a handle to a window and a notification command, the window handles moved to 32 bits, therefore there's no room for the notification command. The ID is still 16-bit and the notification command is still 16-bit, so we combine those in WPRAM on Win32. But this means that both the tests of WPRAM and the tests on LPRAM need to be checked and generally modified when you move to Win32. So here's the examples. You're going to do a switch statement on the WM param. to see maybe what menu item has been selected or so forth, or what button has been pressed in a dialog box. This is not portable because WPRAM might have something up in its higher order 16 bits. The following code is portable, so if you and you can recompile on 16 or 32 bits by just taking the low 16 bits of WPRAM all the time. And so this is now portable code, and it's a fairly simple change. There are a number of portable or a number of ways to handle parsing the information out of the high word, the notification command. You could either put an ifdef in the code yourself, in which case you'd just be taking the high word out of WPRAM instead of LPRAM. Another option is to use macros. And what we've done, there is already a full set of message crackers that are portable that were provided by Neil Konzen in the Win3.1 SDK. And so we've taken those, the message crackers already available, and ported those to Win32. So if you're using those today, that's one way of having portability. We've also added in a bunch more message macros or macros that allow you to parse things like the WM command messages in a straightforward manner. And again, those are all located in the Windows-X.h header file. That is not included by default. That's something that you'll need to pull in if you want to use the message crackers. Some folks religiously believe that macros hide and are actually cause some debugging issues, and it will use ifdefs. There are going to be relatively few ifdefs that you are going to need. Some people believe that's a cleaner way of doing things. Other people find macros to be much more readable, much more understandable, and may choose to use some of the macros in Windows-X.h, and that decision really resides with you. But we have the information and the macros there for you to use. Get class word, set class word, window word, and set window word. We argued back and forth as to whether to change the semantics of this API so word really meant 32-bit value, but then that turned out it probably broke a lot of people. And so we decided to leave the semantics correct. This is an API that even under Win32 manipulates 16-bit data. Unfortunately, there are some predefined identifiers like handles to cursors, handles to icons, which are now 32-bit values. So we've had to move those definitions out of get window word into the get window long APIs. So if you compile, you'll note that if you use these IDs that they no longer are found, then you need to change them from like GCW to GCL and so forth. If you are putting user-defined data into window extra words, take a look at what kind of data that you're putting in there. And if it's grown to 32 bits, you're going to be lopping off the high 16 bits of most everything you put in there. And that may not be what you intended. And you probably need to move that over to window words or class words. Fortunately, Windows is a rich API set and sometimes has multiple ways to do the same thing. So in this particular case, there is a call of get parent that will return the parent window handle, and you don't actually have to grovel in the window words in order to get that. If you can use a named API to do the same thing, I encourage you to do so. That's much more portable and more readable. So that's basically highlighting what the message issues are. And WM command, again, is the primary one that everybody is going to be dealing with. There also were some API changes that we've had to make. As a general rule, if we could just support an existing API by widening, we did. If we wanted to add new functionality and we could do so without breaking an API, we would do that as well. If the new functionality did affect the portability, we added it as a new API. That's how we ended up with a virtual alloc that supports sparse memory and a global alloc that does not. Messages, there was nothing that we could particularly do in the case of WM command. We didn't want to come up with a new message name because we weren't even going to support the old WM command name. We couldn't add messages back into Windows 3.1 for portability because the concepts of a 32-bit WPRAM didn't exist. But in the case of the APIs, there were a few dozen Win32 APIs that we had to redesign because they weren't portable. We added those portable forms back to Windows 3.1, and those are documented in the Windows 3.1 SDK, and they're the easiest method on the API side of creating portable code. So you do a code change once, or if you're writing new code, write to the portable API to begin with. So we'll take a look at some of these functions, and one of my favorite is move_to. Move_to returns, for a feature of move_to is that it returns a packed XY value on Windows 3.1 in the D word of the return value. I don't know that anybody in this room has actually ever used the XY return value from move_to. I'm sure there are a couple of cases. So to assure that the API had the same functionality, we had to add an additional pointer to a structure for that XY return value. C definition today doesn't really support the returning of 64-bit values in a general 32-bit environment. We also didn't want to return a structure. That was also a change. So we added an additional parameter and returned a bool indicating success or failure, much like the rest of the Win32 API set. So this is a coding change that you need to do. But general porting issue here, since most people ignore the return value, is to just add in a null and add the EX in the name. And again, this is an API that is on Windows 3.1 now as well. These are the other set of APIs where you generally ignore the return value, the returned packed XY value that needed to widen to 32 bits for both X and Y. They're these are generally fairly specific calls located in a specific section of your code, and it generally involves just adding null and an EX. There also there's an analogous set of APIs that do return XY values that we all normally use. Get text extent is one of these, in which it returns the rectangle that defines or the extents of around a character string. This particular code fragment is inverting a string that's being displayed. Because of the packed DWXY is now in a structure, you have to make a name change and a code change in order to handle that structure definition. And these are the general APIs which you will need to either add a local variable for the structure and do the name change. So this is a slight coding change, but again, these are also added on 3.1. So once you do this work once, you're done for all time. If you haven't added DDE to an application yet, definitely recommend that you use DDEML. It's a named API that's very portable. There are some issues with DDE messages that Sandy went over in his DDE talk, which just require some repacking of the DDE messages. They're supported, and they're documented in the programming techniques book, and also were talked about by Sandy, so I'm not going to go into a lot of details here. You need to replace any of your int21 calls or DOS3 calls with actual named APIs, and there's a list of that maps these the standard most common set of int21 calls to named Win32 APIs. Another option is to move to the C runtime, which is even more portable. And a lot of the tendency to use int21 is generally in older code, Windows 1, Windows 2 based code, which the C runtime didn't necessarily offer the support that needed to be there, and people generally call it DOS directly. So this is primarily an issue for older code. So moving to the C runtime or the named API is more straightforward. In your initial port, you probably just want to ignore long file names. There is probably a fair amount of embedded logic that assumes an 8.3 file name in one way or another, either in the size of the buffers that you create or in how you parse and look for extensions. So you might want to just ignore the long file name issues in the initial port and then go back and rework those. We talked a bit about DLL, the multitasking impact on resources in the Win32S talk. We'll also talk about some of the changes that we've made in how DLLs are loaded and initialized in the next few slides. So again, if your DLL is manipulating data, that's an atomic operation under Windows 3.1, but under on NT, you can be interrupted. Another application can call into the DLL, and if there's no critical sections or semaphores that guard that resource, it could become corrupted. So you just need to use standard synchronization principles. Windows 3.x has this Windows entry point concept. They're also on the installable device drivers actually offer a feature that's basically fundamental to DLLs in Windows NT. The ability to know when any process is loading you, when any process is exited, terminated either normally or abnormally. You get a notification as to when you leave. There are several samples in addition to this basic sample on the SDK that you receive now. There's a thread local storage sample on the SDK, an old Windows 3.1 sample, select, just illustrating some of the porting issues of moving your DLL, and another sample that doesn't come to mind, but we do have a wider variety of samples illustrating DLL issues in this release. Basically, it's no longer needed, no longer encouraged that you don't to have an assembly language initialization routine in a DLL. It's a standard stack-based calling convention. Any C program can handle the entry point for the DLL. So there has been some changes in what information you're passed during initialization. Basically, there's the reason for being called, and that generally is who's loading you, who's unloading you, and so forth. You also get the handle to the instance for some of the DLL resource loading and things like that. You can control whether your DLL's data segment is shared. By default, it's not. By default, it's per instance. It's unique to each process that loads to you. All the global variables are unique to each instance. But if you want to mark your data, your globals, as being shared amongst processes, you need to make two changes in the def file. Define a .bss as shared that takes care of any uninitialized data, just simple global variable definitions. And you also need to do .data shared to take care of any initialized data like arrays or strings that you defined in global variables. So you need to do both steps. All right, moving on to some of the standard issues with moving code to moving C code to 32 bits. As an aside, Jeff Harbers is going to be giving a talk later on today on Microsoft Foundation classes in C++. This particular talk really defines the portability issues with moving C code from both for the respect of the API as well as in respect of C itself. C++ is far more portable, and the Microsoft Foundation classes were designed fully with portability in mind. All of the Microsoft Foundation class samples just recompile for Windows NT. They're provided on the SDK that you received, so people that are targeting the Foundation classes are already portable, and it is a definite benefit of C++. So this is a very C-specific talk. Okay, general pointers grow to 32 bits. Even the local heap is now basically global, and there's really no difference between a local or a global heap allocation. Pointers no longer wrap at 64K boundaries, so if you're using far pointers and you're taking advantage of some of the interesting features of the Intel architecture where you increment a far pointer and it gets to the top of 64K and wraps back down to 0, that new feature under Win32 will be that it goes all the way to 4 gigabytes before it wraps back to 0, which might not be the intended portable way to handle incrementing a pointer. Global memory is not aligned on 64K boundaries by default. There is a feature of virtual alloc, which you can request that memory is aligned on 64K boundaries. And this was put in at the request of ISVs who have code in their applications today, which really assume a 16-bit selector and 16-bit offset. They pass around the high order 16 bits and then later combine and do some pointer arithmetic in order to add in the offset. It's generally not, this is not a great way of writing true, pure 32-bit code, but for portability you can alloc through virtual alloc on 64K boundaries. Global alloc actually does not have this behavior though, and so this is a porting issue. It is better to remove the assumptions about how you're aligned. Your allocations are generally aligned on 4K boundaries, but even that's a poor assumption to make because we may pack things into a 4K page. Mentioned before that we don't support Win32. It's a non-portable API definition. Same is true for a bunch of the selector APIs in Windows 3.1. There are no selectors on MIPS at all, and really selectors don't mean anything on Win32, even on x86 systems on NT. Integer data types. Integers, again, generally grow from 16 to 32 bits. We do support words which are 16-bit and ints or D words that grow to 32 bits or are 32 bits. You probably want to use specific type defs in your own application if you're not using ours already that really define and differentiate between which of your data types are flexible, which ones can grow inherently when you move from 16 to 32-bit, and which one you really truly intend to put a stake in the ground and say this is always 16-bit, this is always 32-bit, and so forth. Just as with pointers, counters, and masks, you're getting sign extensions, so if you're masking out a high order bit in a 16-bit value right now, that'll get sign extended, and when you do that kind of a Boolean arithmetic or Boolean checks, you may be checking to see whether the high order 16 bits plus one additional high order of the low 16 bits are all ones, which may not be the intended test that you want it to do. Also, counters now wrap it at 2 gig or 4 gig instead of 32K or 64K, and again, that's probably not what your code expects. These are generally things that at least one out of every few folks here are going to bump into. It usually isn't a major problem, but just something that will bite you and an interesting bug when you port to Win32. uint versus word. Uint was actually added in Windows 3.1. We had that added back into Windows 3.1 to start the move to for portability. Uint is a signed 16-bit integer on Windows 3.x, so it's identical to a word, and generally a word was replaced with uint throughout the API. It's an unsigned 32-bit integer on Win32, and for a while we actually used 16-bit values for a fair amount for compatibility, but it turned out we were making a trade-off. We were trading off performance to portability, and truly on moving to 32 bits, one of the primary goals for moving to 32-bit is for improved performance, and so we have used the uint to be a flexible data type that moves from 16 to 32 bits from Win31 to Win32. So these are the type defs. Just unsigned into both type defs are identical on Windows 3.1, and it is truly a 16-bit value for Word on Win32 and a 32-bit unsigned int on NT. Structures. Structures have members which can grow to when moving to the 32-bit environment. That is something that you need to take a look in your own code as whether that makes sense, whether for capacity reasons structure members need to grow, whether they always should have been defined as being a fixed but large size under Windows 3.1, or how you want your packing issues to be handled. You may currently be packing everything on Windows 3.1 today, and we definitely recommend that you do not do that on Win32. Structure packing is a performance issue. For portability, it may be very tempting to pack structures. What you should do is look at how things lay out in memory when you move to Win32 and reorder structure members so that things align, so that each member aligns on a natural boundary. Intel processors have a slight overhead increase when you access unaligned data. On MIPS architecture, you actually take an exception and you get tossed out of memory unless you handle that exception when you access misaligned data. And even if you do handle or allow the system to handle the unaligned data, it is a tremendous overhead because you go through a full ring transition for the unaligned data. So performance reasons, especially on MIPS, do not pack things arbitrarily. Have structure members align naturally on structure, on boundaries. So the general rules on data sizes, both on x86 and on MIPS. Characters, chars are still 8-bit values and align on byte boundaries. Shorts, words are still 16-bit and align on even boundaries, so no changes there. Ints long, 32-bit, fine, 32-bit alignment. Floats are 32-bit values on 32-bit boundaries, and doubles align on 64-bit boundaries, and that's one place to get bit. Structures themselves, arrays of structures, will align on 32-bit boundaries. So because of the alignment issues of arrays of structures, you do have to be slightly careful with the size of operator. The size of operator includes the additional padding that may be necessary in an array of structures, so that when you're walking a pointer down an array of structures, the pointer goes to the right place. But if you're actually making assumptions, direct assumptions, that size of actually truly is the representative size of only the structure members, that's an invalid assumption. That's a feature of C. It's usually not an issue on Windows itself because structures, you generally use the ZP switch and packed everything. There is one structure out of all of the Win32 headers that we do pack, and we packed for compatibility reasons, and we decided that performance was not an issue, and that was the bitmap file header info in WinGDI.h. There are enough people that actually just do a read and write of the header information. It's only used in the file transaction. It's not particularly used during API calls, so the performance hit really wasn't there. And we did pack that explicitly with a pragma in WinGDI.h, but that's the only one. The LPSTR type def has been an abused and overloaded type def over the years, which is unfortunate because in moving things to Unicode, it would be much nicer if there had been a unique type def that only and always pointed to strings. But unfortunately, there are calls like create bitmap and some other calls that they intended to just point to a bit bucket, but decided to use LPSTR as the type def in order to reference that bit bucket, which in fact is not a string, never was a string, and never will be a string. So we defined a new type def in Win32 called LPETSTR, and so it's explicitly and only used in the API to refer to text strings in APIs. You can see what the general type def is here. And when you're compiling for Unicode, it's actually a 16-bit character pointer. And when you're compiling for compatibility just with the ANSI character set, it's a standard 8-bit pointer. So we talked a bit about some of the API changes that you are going to need to make, or some of the changes from handling messages portably. But it is important to note what types of features basically should cause you no problems whatsoever. There's DDEML, we've mentioned, and OLE, which were designed portably to begin with. Resources. For folks here who have transaction applications or database front ends that have hundreds or thousands of dialog boxes that they've created for forms and form entry, those are all compatible on Win32. You don't need to go through your resource files when moving to Win32 at all. Fonts, any font manipulation code in general is portable, even support for things like TrueType. And printing is also straightforward. We've added a bunch of new printing APIs for enhanced features, but generally you can print without any source changes. In fact, one of the folks who came to the porting lab got their application up and running after a couple, 3 days, and decided, hey, I have a graphics application I'd like to print. I never had tried it before, and then they printed over the net to a color printer, and it worked, much to all of our enjoyment. Your help files, it's the same help engine. WinHelp reads the compatible Win 3.1, 3.0 help files, so all your help files that you've created already are fully compatible. on MIPS and on x86. And metafiles, your metafile calls, your metafile themselves are compatible. The code for handling metafiles is compatible when you move to Win32. I just thought I'd toss in a slide just talking about some of the other porting issues. Obviously, one slide really doesn't do justice to full issues of moving code from Unix or other operating systems. But one of the key features I want to talk about was the fact that the console API, the support, the Win32 API implies that it's only a windowing API itself, much like Windows 3.1's API definition. But that's not true. There is full support, the compiler, the resource compiler, and so forth. These are all Win32 applications. They only actually call, or their output only goes to standard in, standard out, standard error, but you're compiling with the same set of libraries. And you're actually generating a 32-bit application, and there are, in addition to just standard in, standard out type support, there is actually a fairly rich hardware independent console API set to be able to do menuing and scrolling within Windows and so forth. And there is a sample on the SDK that really highlights a lot of the APIs that are available, even for sophisticated character-oriented applications. You also have the support of the various subsystems, the DOS and OS2 and POSIX subsystems. And so this, again, for portability, just allows you to take existing apps over. And any code, any Unix-based code that's generally based in C or OS2 and so forth is also very straightforward to in general, carry on over to Win32. I've ported a couple of applications from X Windows to Win32, and a lot of the key data manipulation code is very straightforward to port, and mapping X Windows type issues to Win32 is also there are some model differences, but it's not an overly nasty task. It's definitely more involved than taking a Win 3.1 application, say, to Win32 though. And in moving OS2 code, you have features and name pipes, mail slots and semaphores, DLLs. I mean, there are very many similarities, and quite a bit of OS2 type code is written to the C runtime, and so it is very portable. And we have distributed CD with tools and documentation on the cover porting issues, and there were separate talks on moving PM code and things like that to Win32. So on your developer resource kit, you do have all that documentation.
Okay, so we've taken a look at at some of the things that you need to look out for in your code. Given just a list of messages and APIs to search for, you could certainly go through your own code and look out for those. We're trying to help automate this process, and we've had a couple of versions of a porting tool which we're continuing to improve. There's one that's shipping on your SDK today, and we'll continue to put improvements up on CompuServe. So the porting tool is basically a glorified spell checker, looking for keywords, APIs and messages, as well as you can add your own user-defined type defs or constructs that the porting tool can add. There's a standard text data file that allows you to enhance this tool. So we'll take a look at what the porting tool finds in the RANDirect sample that we just compiled. Okay, and the first thing it finds is the window procedure, and it's highlighting the fact that we need to put in a uint and a uint. Continue along. Finds another reference to WinProc. Again, it's just basically token based. It finds the actual function itself. Uint. Uint. Continue along. The current data file specifies low word and high word to be looked for. You can actually disable that. Thought it was a good idea to highlight these things, sort of human interaction here. I mean, those things are going to whack out 16 bits out of whatever you passed in. That may not be portable. It's about a 50-50 chance, maybe not even quite those odds, as to non-portable uses of low word or high word. So it's really something you have to do under human observation as to whether these are a problem. In this particular case, this is the WM size message, which is not a porting problem, so we can just continue along. Okay, that's all it found, therefore that must be all there is. And so we can save this. There it is. Done. There we go. And we recompile. No warnings. The warnings on the link indicating additional libraries that are being referenced that Mark Cliggott talked about. And now we bring up RANDirect, and we now have a ship quality application. The invisible menus are no longer there. Things seem to work. And so that basically was the only change that was apparently needed, at least from the porting tool, on the basic API and message issues. There's another sample brought along, which is justifies text, or shows text manipulation, again, that Charles Petzel provided in his programming Windows book. So let's take a look at what Port Tool finds in this particular application. And to save time typing, I'll just show you what it finds. Again, window procedure. Move to. Get text extent, which needs to be changed to use a structure. There's a low word reference to the packed X and Y value that's returned from text extent. So this is a section of code that needs some porting work. Another reference to get text extent and its packed values. Window procedure again. We're adding more and more suggested changes, and the tool will also will allow you to will make suggested changes that you can do automatically, just like a word processor, so that you can go through a lot of the code like this, set window extent, just add in the EX and the null. And this is basically the only change that would be needed. We'd like to just make that an automatic change. So you continue along. Same thing for set window org. Make point is now replaced by a macro in Windows X.H called long to point. And W of command needs to be looked at. So we have references to W param here. Almost certainly that needs to be a low word W param. Switch on W param needs to be a low word W param in order to be portable. So continue along. So basically the porting tool just brings you to various sections that need to be reviewed, and we'll add in some of the automatic support so that you can quickly take care of the obvious changes. We'll also add a support where it will put in a comment line before every single one of these statements in a background porting mode. And so then you can use the editor of your own choice to actually go run through and find what the porting tool has found in your own application. So I've actually made the changes already in a separate file. Recompile this. There are some warnings, issues that really should be taken a look at from portability, conversion between different integral types. Yeah, that's generally a porting issue that probably should take a look at. But again, since this has managed to compile, I'm game. And sure enough, seems to come up. Change the fonts. Again, none of the APIs or messages that we bumped into in the porting tool reference anything specific with fonts or any things like this. And yet this is able to actually take care of all the standard, do centered, alignment justified, my favorite, small fonts. Great way to send email to people. Anyway, so this is just illustrating that they're basically, the porting tool allows you to go through the process of finding the necessary areas that you're going to do changes. You can extend it with your own type defs that you could look for, so it is extensible, and we'll actually make the source code all available. It's going to be part of the MSDN CD. We'll probably put it on the SDK as a sample as well. There'll be a DLL version so that you can hook it and extend it into existing editors. We just have found it to be a useful tool in the porting lab and want to make this available. In a combination with the spreadsheet and the documentation, it really should be useful for finding porting issues.
Okay. So that's basically the porting talk, and open this up to general questions. I guess we'll just start off by going upstairs. Give people a second to get to the mic.
In the previous section of your talk, you mentioned some things about Win32S and shared memory and DLLs. In one section of the talk, you talked about using named shared memory. Were you referring to great file mapping and its related functions there?
The question has to do with memory map files and named shared memory. Those are actually two specifically different but supported mechanisms for supporting shared memory. Named shared memory is there already in Win32S, and a popular request today was to support memory map files in Win32S. Downstairs.
Are there any portability issues that would not be identified by compiling with highest warning level with no warnings?
Are there any portability issues that would not be found by compiling with a very high warning level? Absolutely. I ran into one the other day that was very specific to MIPS. There was a complicated mechanism for allocating structure sizes. And sure enough, through the arithmetic of dynamically allocating the structure, C thought it was great, and MIPS just hated it and caused an exception. It was easy to find in the debugger. Compiling at a high warning level is a very good thing to do, and we generally recommend warning level 3 or higher. Downstairs.
Those of us that have just cleaned up our code for C7 have added things like callback and wparam and lparam as types. Why in your code aren't you using the C7 conventions?
Question has to do with some of the new type defs that are present in C7 or the SDK that's bundled in C7. We actually, this is some older code fragments here. We do fully document, do use all the type defs, wparam and so forth in the headers. Some of this is just like yourself, we were affected by Windows 3.1's type def changes. And so we have rolled in most of all of those type defs in the current header files. I think we have a couple more header files to deal with. I believe you will not bump into anything that's not defined, but you may still see some sample code and see some of my, things like my slide that still have some references to some older type defs. So that's my apologies. Next question.
When doing new code for Win32, how do you choose whether to do C library or the Win32 API?
Question has to do with why would you make a decision? What decisions govern going to the C runtime versus the API? Primarily an issue for folks with writing new code. C runtime has some additional overhead, say in number of objects that get linked in on the the level of granularity of the object modules themselves. There's some additional overhead maybe in some of the calls. The memory calls like malloc pretty quickly turn around and call the Win32 APIs. So if you're writing a smaller application, the API is generally straightforward to use. The C runtime provides you some additional support and protection on some of its calls and some ease of use, as well as portability issues of taking existing code over, say, from Unix or even DOS. So there's no hard and fast rule. I'd like to post information up on CompuServe, and we'll try to get it into the final documentation on what types of APIs or what type of work is done in a number of different runtime functions. So you have a better idea of whether it makes more sense to call an API or not. But in general, I would recommend the C runtime. And the C runtime just doesn't cover quite all of, or in fact, all of the API. Okay, upstairs?
Just a quick follow-on to the previous question about name-shared memory. What is the API set that's used with that feature?
Question is, what is the API set, or the actual API that is used to allocate named memory? I believe it's a parameter that's specified on virtual alloc, but I have to go and take a look at the online help. It's a optional parameter on memory allocation.
Great, thank you. They keep cutting our mic off up here, so
Okay.
we can't finish things.
All right, upstairs again.
I'm still confused about sharing of instance data in Win32S DLLs.
Sharing data in DLLs, is that the question?
It's instance data.
Instance data. Okay, by default, if you don't do anything when you're working with the SDK today, you create a DLL, the DLL's data is going to be private on a per instance basis. So if you have two applications that both reference the DLL, and there's a global variable int foo will be set to 5 by one application, and it could be set to 4 by the second application calling that DLL. They have private copies of that DLL data. Then if you decide, okay, I want to mark my def file as being shared, if one application sets that value to 4, that will be reflected immediately in what the other application would detect if it were to query the value of foo when it called that DLL. I don't know if that answers a specific question. Next question, downstairs.
Hello. Will there be a debugger in the Win32S package?
Question is, will there be a debugger in the Win32S package? We will provide, or there already is, the GUI windowed-based Win debug provided in the SDK that you have today. We'll enhance that as part of the SDK, and that will be the primary debugger for doing Win32S development with this kit. Borland, languages, other vendors who provide kits for DOS, it's their responsibility and their opportunity to provide debuggers with their toolkits. So it's not really a feature of Win32S, it's a feature of the toolkit itself. But yes, you'll have debuggers to do debugging on either platform. Another question downstairs.
I have two questions about resource formats. The first is the bitmapped font format. Has that changed in Win32, the .fnt?
Question has to do with the format for bitmap fonts on Win32, and the format is identical with Windows 3.1.
Okay, the follow-up question. Does the kit that we've been given contain information about the executable file formats?
We need to post the actual up-to-date file format on CompuServe. We have enjoyed changing the format almost every week and basically couldn't get that into the documentation. And even if we did, it would have been 4 weeks and therefore four changes too old. So we will place that up on CompuServe. The format is now stable. We've just been generally affecting our own self, and a few of the early tools vendors here have not particularly appreciated this. But yeah, the format is stable. We are going to make the calling convention change. but we'll get that information up on CompuServe. Another question downstairs, and then we'll go back upstairs after that.
Yes. My question was basically, I noticed that one of the things that didn't make it on the list was the multimedia API. Is that correct?
This sounds like a question on multimedia support on Win32S, and it's not in what we're going to distribute in September, but clearly there are people doing work to support the multimedia sound capabilities. It's not a technically challenging job to provide the funcs. It's a scheduling issue, and we are interested in providing that.
Wouldn't it be very simplistic to at least add play sound or just that API, because many people are using that now?
Yeah. We'll definitely try to get the rudimentary support in and see what we can do after that. We have the ability to rely on some other resources in the company to actually do some of the support, but the actual folks working on Win32S themselves have enough to keep them busy for the rest of the year. But we'll go out and work those particular issues for multimedia, PIN, MAPI, and so forth.
Because the flat address space would give us more abilities as far as the large amount of data is in that area. So that's why I'm very interested in it.
Right.
Unfortunately, can't use it.
Yeah, particularly PIN and sound are both data-intensive applications. So I understand the request. Upstairs.
Do you think we'll still need to add memory management functions to improve the speed of malloc in Win32 and NT, or will the C runtime malloc functions be pretty fast?
The speed of malloc it should be quite fast. They really do go quickly, almost immediately. I think if you actually take a trace through a malloc call, you'll see that they go off and call a heap function basically immediately. So there should be really no overhead on the malloc call.
That includes doing thousands of small allocations?
Yeah, they generally do a large allocation up front, and then they do a quick sub-allocations after that.
Thanks.
Another question upstairs.
Yes, I had a question about DPMI support. In your foils, you mentioned that the applications supported the DPMI 0.9 and the device drivers did not support the locking of pages by applications, which is provided by DPMI 0.9. And I was wondering specifically about the support of memory mapped devices and being able to get them into the address space, and whether you had any plans to move to DPMI 1.0.
Okay, I think there are at least 5 answers depending on whether we're talking about the DOS and Windows compatibility support. The DOS Windows compatibility support on the Intel architecture and supports the 0.9 DPMI. We have no plans to support 1.0 in Windows NT for the release this year. The additional issues on locking pages, my particular reference was for Windows applications. It wasn't addressing the compatibility of running existing DOS or Windows applications. It doesn't make sense for a Win32 application to try to lock pages because they can't handle interrupts. They can't directly talk to memory mapped hardware. You need to have a device driver. I think there are enough other issues in your question that we probably should meet afterwards. But on the DOS Windows compatibility issues, we are talking about, and I think we're going to have a note here about supporting a generic device driver interface that I think half the people in this room have asked for, which would be the support that you're looking for. Another question upstairs?
Could I ask one question real quick? Is it going to be possible through a device driver to support a memory mapped device?
Is it going to be possible through a device driver to support a memory mapped device? The answer is yes, and I'm answering yes in the Windows NT device driver model. Question downstairs.
Will we still be able to debug on a secondary monitor?
Question has to do with debugging support and secondary monitors. The short answer is no. The issue is that we're not going to make the debuggers create device drivers in order to support multiple monitors. What we would like to do, it's not currently in the Windows NT product this year, but it's to fundamentally support the notion of multiple desktops. And to have multiple displays of different resolution, same resolution, whatever, in which you could have multiple desktops in order to do work on. And so the debugger would just support that inherently without any specific features. It would take a device driver itself in order for a debugger to do multiple monitors. Now, it's certainly not something that we're going to do in the WinDebug debugger. So that'd be something that another vendor would need to do. Another question downstairs.
The last talk, the picture that you gave, the block diagram of the Win32S architecture.
Yeah.
How can I get a copy of that?
I'll put either something up on CompuServe. I've got the slide here. If we can print it out somewhere, or we can distribute some printouts. I'll see if we can get some printouts up, say, at the information booth later today.
Thank you.
Downstairs again.
Yes. Does it seems like you've repealed a lot of the rules that were left over from real mode programming. Is there things like you've defined near, far, Pascal are all nothing now? Is that true?
The definitions of near, far, Pascal, a couple others, yes, are all pound defined to nothing.
Yeah. Is there going to be some kind of a reference that would help us generating new code for NT sort through which of these things are really historical and obsolete, and which things are still required?
The question is, what about some of the moldy oldie APIs and messages that have, date back to Windows 1.01? We are marking the documentation obsolete APIs. We still have not made a decision as to what to do with very tired APIs that really have improved functionality. On one hand, for compatibility, we think we need to support these for all time. On the other hand, the documentation is now about 2,000 pages for the API, of which most people aren't calling some of these APIs. So we are documenting the obsolete ones. We haven't decided what to do now that we've marked them obsolete.
Yeah, actually, I was more concerned about coding convention in general. If you're in the habit of defining all your functions near Pascal, should you stop doing that?
Well, in this particular SDK, we don't have the hardcore Win32 application. We are going to have more samples and documentation that specifically says, if you're just thinking about Win32, here's how you would architect your application with threads in mind up front for printing. You don't need to use WinMain. You can actually use main as an entry point. Use standard argv, argc for parameter parsing. We definitely want to have what opportunities there are in coding for a native Win32 application documented, and those samples will begin to appear in the September release. Next question, upstairs.
Yeah, is there any tool planned for profiling Win32 apps running on 3.1? In particular, is there any direct way to measure the cost of the 32 to 16-bit call funcs?
Question has to do with profiling support for Win32 apps on 3.1. We have several internal tools that we're using to performance tune and test applications, and we definitely want to productize those. It's also possible to at least API profile Win32 apps given existing support just with a standard profiler that's in the 3.1 SDK. You can track, since 16-bit APIs are actually doing the work, you can actually profile what APIs are being called and what percent is being spent in those. We also need to provide, and will provide, the call profilers as well for doing your source profiling. So we have a handful of possible profiling tools that will become available as we go through this pre-release program. Question upstairs.
I'm a bit confused about the restriction on port I/O. As we don't get the DDK yet, we are in a situation where how do we get port I/O? You say put it into DLLs. Can you just give us a strategy for how to solve that?
Yeah, the issue is, we said that we're not going to support direct hardware, but yet we haven't given you a DDK either. So that means, in the next couple of months, really this would be the application porting time You do need the DDK in order to write a device driver for Windows NT. You do have a DDK on the 3.1 side. The only information I was trying to present on what you might do with a DLL today is isolating your port I/O into a DLL on Windows 3.1 at least allows you to be targeting a Win32 application, defining your interfaces to that DLL. That DLL would be replaced, say, with the next release when the DDK becomes available, with an NT compatible DLL that made an ioctl call to the NT device driver. So it's definitely incremental steps, and we don't have all the pieces here for you to do the device driver work on NT right now, but will in the fall. Downstairs.
Hello. What's involved in porting the RS-232 API, the COM functions, and are those thunked properly through Win32S?
Question has to do with a serial API COM support. We did do changes in the Win32 API to add functionality to serial port capabilities, make it more robust, and basically fix some errors and problems that there were in the 3.1 or 3.x design that are historical. This is a compatibility issue, and it is one area where you are going to have if-defs or fundamental pieces that could be different between Windows 3.1 and Win32. What I'd like to, we can meet afterwards, or people who have specific COM uses, we could talk about some of those specific issues offline. I don't think it affects a large number of people, but we'll make those notes available separately. Another question downstairs.
Yes. It wasn't clear in your talk how the compiler will address aligning structures that contain doubles. You said structures were 32-bit aligned and doubles were 64-bit.
Yeah, the issue is on structure alignment. If suppose you have a structure that has a mixed set of members, suppose that there are a couple of doubles in there. The alignment, the doubles are going to take 64K alignment. 32-bit alignment is a natural division of 64-bit alignment. So if you had two structures, both with two double members, you would get them all packed contiguously into memory because it falls naturally, the boundary falls naturally on a 32-bit value. Let me take a couple of questions. I'm getting a time out. So I'll be heading out to the room outside and can take other questions out there. Thank you.
We've had a slight change to the schedule. We were supposed to go to break at 10:30 and then resume at 11. And the 11 o'clock presentation was supposed to run for an hour, and that's actually going to be a 30-minute presentation. So we'll be on break now till roughly 11:20. So if we get back in at 11:20 to 11:25, that'd be great. Thank you.
Hi, we hope you found the information in this video valuable. Before we leave, we'd like to give you a quick look at Microsoft University and some of MSU's other services. As part of Microsoft's Education and Consulting Services Group, MSU provides technical training straight from the source of the world's most powerful software systems. You get the knowledge you need to have an immediate impact on your productivity and your bottom line. Microsoft University provides a broad range of courses geared for different audiences at various skill levels. MSU courses are always timely and based on the latest versions of Microsoft software. The courses currently offered cover these products: Microsoft University offers a library of video courses like this one for support professionals, as well as a separate library for programmers and developers. This self-paced training option offers many benefits, especially the ability to leverage your training investment. Microsoft University provides hands-on lab-based training at 10 regional facilities in the U.S. and Canada. Students are removed from office distractions and can focus fully on their learning experience in our state-of-the-art classrooms. If you're looking for a cost-effective way to train more than 10 people, check out our on-site courses. Microsoft University will bring the instructor, student materials, and expertise to your location. Another way to take courses closer to home is through the Microsoft University Training Alliance program. Members meet exceedingly high standards. Their instructors are trained by MSU, and courses are identical to those offered at MSU locations. Unique training needs are often best met by a custom course, solutions-oriented training tailored to your company's needs. Custom courses can be taught by MSU instructors or licensed for delivery by your own internal training organization. Finally, to help corporate decision makers understand the rapid evolution of today's technology and how they can apply it, MSU has developed a special series of high-level executive seminars on tour in major cities across the country. That's a quick overview of one of the most powerful training resources in the microcomputer industry, Microsoft University, dedicated to not only what the industry is today, but to what it can become.